Okay, so guys, I thought I'd show you all a project I've been working on. This is IDE for Rust. As you all may know, Rust is one of my favorite languages. Usually these days is Rust, Go, C, and Python. But Rust really has a special place to me. It's one of the few languages you can do anything with. They have the power. C with the combined with the power of a high-level language, something like Python or Java. You get really cross-platform across the entire hierarchy. You could do anything from programming a microcontroller to really building with applications, and that's a powerful feature set to have. You learn one language, you can basically do anything. Every language is a tool, but Rust is just one of those languages that really powerful in its own way. So this is the application. Well, I don't have the source code to show you all. I'll probably do it some other time. Basically, application written in C, Rust, and Python. Python does a lot of the heavy lifting on the GUI side, and while Rust and C helping with scaling up. So when you launch it, you get a nice splash. This is version 1. I have the option to create either a Rust application, which is for like you're doing desktop or web, and or a Rust embedded application. This is what I'm working on right now, really getting full integration, probably looking at optimizing the compiler for embedded microcontroller architectures, or just probably enabling special compiler runtime flags or flags in the compiling to ensure that we get the smallest binary for microcontroller architectures. But I think let's demonstrate the application for now, since this is still a work in progress. So when you launch the IDE, you have this ASCII art with the Rust logo. So some of the features the application provides, specialized Rust language support, integrated cargo build system, of course, Autocompletion for us, real-time Rust code analysis, debugging tools, and the debugging tools is GDB, actually using GDB-MI interface, so you'll be able to get good control. I prefer to use GDB-MI because it's just what I'm accustomed to at this point, and it was easier for me to design a graphical user front-end for it rather than using GDB, and of course you have all the power GDB behind it. Built-in terminal abstraction layer, the ability to launch external terminal, of course. This is my customized Rusty Monolith theme, so the theme system I use is reflecting Rust as a language, a lot of Rusty colors. Autocompletion, we have bracket highlighting, find a new place, linting, of course. Automated code formatting, bookmarks, project support. We just create a project. I integrated AI bar and code folding. Code folding is actually in beta. The block comments is complete, but the code folding in beta. Direct integration with the Rust libraries, and of course Create.io. Get the typical shortcut, save, cut, copy, paste, undo, redo. Of course, I can mention block comment. So basically, this is what you will have. So let me explain how the IDE works. So I think I'll start with the terminal abstraction layer. Now, our problem with plenty of IDEs is that when you're writing code, the IDEs sometimes crash a lot. When using the IDE all day, especially like for me, use the IDE extended period of time, eventually the IDE is bound to crash. So by using a terminal abstraction layer, basically you're communicating with the subprocess, subprocess with the underlying terminal thing your operating system is using, and by doing that, if the terminal at your launch crashes, the entire IDE wouldn't come down with it, so you wouldn't get any code loss and stuff like that. If you want, you could also have the option to launch external terminal. So if you have special build requirements, you don't have this terminal abstraction, you could also use the external terminal if you want the more powerful features of the terminal, and this runs external to the IDE, so of course the IDE wouldn't crash. So you have something like you know, this nice long bar here that you could type commands in. So you have a standard commands. You know, you could open files, you could, you know, look at directories and stuff like that. The reason why I see this is because I actually had the debugger set up. I was experimenting with debugger specific commands in the command line, but you're able to do all the command line stuff from here. So right now, any command you put into this terminal abstraction layer, will try to run it through GDB, GDB. But that is a feature experimenting with. Once that feature is turned off, you'll get a regular interaction with the command line, and of course you could refresh the terminal. So we have the snippets window, but before we get the snippets window, I think I could show you all process to create a new project. So you could, you know, create a new project. You know, in directory you're choosing, you have, you know, the option to open an existing project. You know, you could create a new file. You could open, you know, the directory, the Explorer. We have the option to save, save as, of course, close. These are shortcuts. Now, these are available as shortcut keys as well. Control 1, 2, 3, 4, 5. But I also have this nice little ribbon here because, you know, sometimes when you're doing programming, you really want to have, you know, quick access to get rid of things. So you could quickly get rid of the Explorer if you don't want the terminal. Quickly get rid of the terminal. Quickly get rid of the AI bar. You can even get rid of the code window if you so like. You know, the snippets bar, you could get rid of anything with this, you know, easy access. We have the option to build the Rust project. So you could build the project without actually testing it. So I have, you know, this project here. And, you know, we could build, you know, it'll, you know, build it without running. We have the option to run the project. So this is a simple Rust program. This Rust program will just, you don't have a number and increment it and then print results in terminal. So if we run that, you know, we see it in the terminal. Really fast and snappy build. No need to wait. It builds the bug by default. I may integrate the option to add debug or release. But then if you wanted to release, you could always launch external terminal and do your build from there because, you know, it's in the same directory as the cargo project that was created. Of course, you have the option to debug. I'll go through debug after. You have find and replace. You know, right now I'm doing file level find and replace. I was thinking about, you know, having my external server running and, you know, so you can search across the entire project. I was exploring different options, exploring the performance. But, you know, file level for me personally, file level usually works, especially for, you know, Rust projects. You know, all the powerful tools they build and it can catch a lot of errors. So, but of course for refactoring, you know, you want the cross file access. So let's say we have loop, we could have loop, and you want to replace it with, I don't know, moop. You know, we could find it and replace, find and replace, and you know, we get a replacement. Oh no, it has option to replace all. And of course we could you know, Control Z to undo. We have option to format the code. So, you know, Rust has a lot of features built in for formatting code. So, but you know, I do the command line with this button. You know, it goes through, it automatically fixes your code for Rust format. So, you know, once you have things out of place, show the example here. You have this comment. You know, out. Click the formatter, it formats your code automatically. You know, we have Clippy for doing linting. Well, not linting, but you know, Clippy checking the code. And so, for example, the project is named not in snake case, I name it test debugger, but you know, here we have Clippy telling us it's not snake case, so we have that. One of the things I want to get rid of is when you usually do a build with Rust. You know, the output is very noisy, so to speak. We have a lot of stuff that is output, but you know, with this run, the run eliminates all of that, so you get a clean application you expect. And if you want to run the checks, you use Clippy from here. Then of course you have home, you can return to home, and then when you run back, the application is still there. A lot of features built in, so let's start one by one. So of course we have the Project Explorer. So in the Project Explorer, what the Project Explorer does is that you have the option to create new folders, create new source files, regular files you could rename, you could delete stuff. Of course you could click on stuff it opens within the IDE. One things I do is, once a file is opened in the IDE, it prompts you to save, because sometimes you open a file, in the haste you just close everything and you lose stuff. I didn't want that, so once you make changes, of course, it will prompt you to save the file. And once you open from the Project Explorer, it will prompt you to save the file whether you make changes or not. This is a safety feature that I put in. It's something that everybody will agree with, but it's something that I find useful for development. So once you create a new project, this is the structure the project will have. A typical cargo project. Of course, a build application. So that's the Project Explorer. Next we have this what I call the Snippets window. So from the Snippets window, what you could do is you have the common use constructs in Rust. So example, a function, you just click on this and you get a function inserted. Now of course as a kind of something like Copilot to do the actual insertion. But something that I found is that AI assisted coding, for me personally, you want to think while they're coding, so you really want the AI popping up these suggestions. There are constructs you want a function, you want a looper conditional, you want concurrency aspects, structure, enums, null safety, architecture patterns, design patterns. You click it and puts directly into the code editor window. But I didn't want like an AI only time, because it not only reduces the speed at which it does stuff, but for me it runs a little slow. That's the reason for creating this IDE. Everyone is using Visual Studio Code and stuff, but we do have a dedicated Rust IDE, and I like stuff fast. So this IDE is lightweight, so it has the performance of like a lightweight code editor, but with features you expect from an IDE. A nice hybrid solution, right? So it have a lot of options for a lot of different stuff here. You command data structures and algorithms, basic design patterns, architecture patterns. You also have the option to add custom. You could add your own custom code if you like. So you have your snippets right through, and it's persistent, so it will last. Once the application closes, it will still last. Now on this side here, we have the AI bar. What the AI bar does is that the AI bar will allow it to interface to ChatGPT. So you could send through the ChatGPT API. Of course, as a kind of something like GPT-4 for could have for the heavyweight IDE, but my plan is to have 2 different tiers of the AI integration. You have something like ChatGPT, where it is you connect via the API, and then you could use something like GPT-4, where you have the full everything running offline. Probably do some custom training on the models, particularly on Rust. I already started looking at using a distilled GPT-2 model for doing particularly training on Rust documentation and Rust code that I wrote, and probably scraping GitHub for Rust code. Of course, respecting the individual licenses are the persons to do the contributions, but basically you could send and clear. And see, I exceed my current quota from my plan, so this was just because I was doing a lot of testing. Of course, I use GPT-4, but for who want the option to use the ChatGPT API from within the IDE, the other option here. But of course, I use GPT-4, but can be a bit RAM intensive, so something else considering. Now you have the code editor window. Now from the code editor window, you have the option to control ++. you could zoom in, you could zoom really far in. You know, you could zoom in as much as you want to. Basically, no limit. Why somebody want to zoom that far in, but it's there. So you could zoom in and you could zoom way out by just holding Control and minus and Control plus. You zoom in and there's a limit of 5 you could zoom out obviously, but you zoom in, no limit. So you could adjust the size as you like. Initially I had the pinch to zoom with the trackpad, but I disabled that because something I just do sometimes is scrolling through code and you happen to have your 2 fingers and it scroll in it zoom in a little and then you lost the whole chain of thought. Of course you have the option to block comment and block uncomment code. You have the bracket highlighting. So of course if it is you're missing a bracket and it will indicate that it have none, so it could give you a matchup. You get in everything as you type, code completion. So let's look at some you get code completion taking place, syntax highlighting obviously, smart indentation, basically everything you expect from a regular IDE code editor. Try to integrate as much as possible. I just trying to set bookmarks, so you just click on you can set up bookmarks when you scroll through your code. Like I say, code folding as a work in progress, because I'm looking at the efficient way of doing it. I'll demonstrate after what I have with the code folding, but let me show you the debugging features for now. Alright, so I forgot we had dead code, so you click debug, bug, and we get the debug window being launched. So this is GDBMI. Of course you get all the output being spit out. Some people not prefer this, but for me I like to see everything, so you can know exactly what's going on within the application. So of course to launch, you do a break 10, and we break at line 10, then we run, or if you want to could run from the shortcut key. So you have this option here, toggle the registers, so you could get irregular registers, or you could get all the registers, right, from GDBMI. You could run, you could pause, you could step, restart, step in, step over, step out, and of course clear the output. So if we do something like we step over, you're seeing the disassembly view, you're seeing everything being updated. You're also seeing the line now. Why I chose this over having it in the IDE is because I'm actually not using the Visual Studio. I'm not using Visual Studio. So using that device because I'm not using Visual C++. And when you're not using Visual C++ on Windows, when you try to step into, you can actually access the libraries, because I believe it's like object files. But this way, if we step in, we could still see, the line numbers, and we could step really deep into the, if you want to step in the standard library, you could see the lines, the line numbers, and that's only able to do with the graphical front end because of how, how Rust is distributed. So this assembly view registers, this is it for debugging. Usually you just want to see stack, you want to see line number at the error. I prefer this way, because I custom working on the terminal. So people prefer, my interface on the graphical user side where you click any button and you step, but I just prefer the terminals. And I know a lot of system developers will prefer terminal where you could see every single thing. Maybe I might have a mode where it won't be as verbose, because you see, and I'm already seeing the stack, this is sending me register information, so you might need to repeat it here. And then of course you close, and when you relaunch the debugger, start a fresh debug session, right? So basically that's just the IDE. We have core functionality, and of course all these windows really fluid. You could just snap anyone and close anyone. if you minimize the application a bit and you pull to one side, you know, this really good for like learning. You just really want everything good. So yeah, that's it, just the IDE. And yeah, so that is that's the IDE so far. You know, anybody commenting, watching good by time of features I'd like to see. You know, the team, of course, I'm looking at teaming. You could do external teaming. And as a product, I plan to have a community edition, and of course, a edition where you get everything configured out of the box. So just download, and everyone able to write Rust code, able to debug Rust code, able to, you know, run the microcontroller systems. Just plug in here, debugger, and run Rust programs on the debugger. You know, debug STM32, SAMD21, PIC32. You know, those are the targets. The Arduino, the 8-bit AVR is not really suited for Rust. I really don't think 8-bit AVR, it's possible to be done, but for really getting, you know, good dev work done, and you know, it was something to a lot more memory, because, you know, Rust was kind of configured for 32-bit, and that 8-bit system really work well. So that's it, guys. You know, I hope to get some support on this project. And you know, it's a very time-consuming endeavor, because everything is done from scratch. You know, down to the syntax highlighting and the indentation and stuff was done from scratch, because we really have a lot of Rust language support for stuff like that. So my plan, instead of, you know, looking for existing code editor or something and customizing it, I decided to write one from scratch, so that way I get the performance I want. It's very lightweight, very fast, and you know, we're able to get all the features we want. So that's it, guys. Thanks for watching.